So I want to talk about how we can go fast with biomarkers of aging, both how biomarkers of aging can help us go fast and how we can go faster to get to them. So I'm just going to start talking, and if the slides come up, the slides will catch up because there's a lot of slides. So, okay, cool. So the first point here is aging is urgent. I don't think I need to talk too much about that with this group. But we've all seen this kind of graph. We have something like 100,000 people dying every day because of aging-related causes. In addition to that, there's years of suffering involved, and there's going to be a lot of economic problems because of it. So we have to move fast because it's an urgent problem. When we talk about moving fast, I think it's really important to think about how are we actually proving our work. So we think maybe we're doing something that's going to solve aging. How do we demonstrate we're actually doing it? So one option over here, we could do. This text is actually a little hard to read. Human lifespan trials. Nope. It's even harder. All right. So if my slide were here, on this side it would say human lifespan trials. Nobody is doing human lifespan trials because they're too long and they're too expensive. And then over here, if my slides were here, it would say Longevity Biotech. So Longevity Biotech is mostly looking at getting approval for age-related diseases, which you can do, but it's not really proving your work because we already have therapeutics being approved for age-related diseases and they're not solving aging. And then in the middle, we have kind of some other interesting approaches like the TAME trial that's looking at health span, looking at multiple age-related diseases, or the Health Span X Prize, which is looking at performance-related measurements. And both of these are really interesting, but they involve a lot of money and they're going to take a lot of time to actually get to these proof points. So one thing that I learned from software, and there's a lot of people here in software, I think, so they'll be familiar with this, is that the faster you can get feedback on any problem you're trying to solve, and the better that feedback is, so both speed and quality are important, the faster you can solve that problem. So you might have some idea of how to solve a problem, you go and test it, and then you get feedback, and based on how good that feedback is and how long it took you to get that feedback, you're going to then be able to iterate at a certain speed. All right, so we want to move fast, and if we want to move fast, we need good, fast feedback. So aging is a really complex problem. This is the hallmarks of aging. There's many different ways you could categorize all the different things that are going on, but there's a lot of them. And so I believe that this is a machine learning problem. So a lot of the things that we can measure that are interesting, different kinds of omics, maybe wearable data, these involve hundreds, thousands, tens of thousands, hundreds of thousands of data points. Humans are not fit to sort through this data and identify what's important, identify the important insights that are happening there. So we really need to be able to train machine learning models that are going to be predictive of human health if we want a good feedback for the therapeutics we're trying to develop. All right, so we want to move fast. We need fast feedback, and the only way to do that is machine learning. So the great news is people are already working on this. This is a collection of some models that people have put together, trained on methylation. You can't really see this at all. This is trained on proteomics. We have this fun model over here that's been trained on accelerometer data, and they're all interesting, predictive of mortality, of health outcomes. But the problem is that the data that these are trained on is very limited. So we don't have data sets that have multiple different types of data, so it's really hard to compare. Is the methylation data or the proteomic data doing better in comparing out and getting outcomes? We don't have any public data sets that have things like omics and mortality, so these models are trained on a data set that the researcher has access to and then tested on a data set that the researcher has access to. So again, it's hard to compare how these are doing in a kind of objective fashion. These data sets are cross-sectional. Feature count is often so large that it exceeds the number of samples, especially for methylation clocks. So that kind of limits the kinds of models that are going to be effective in the kind of training you can do that's effective. All right, so if we want to move fast and we need faster feedback to do that, we got to use machine learning because of the complexity of the problem, and we need bigger, better data solutions. So there's a lot of work being done in this, but I'm going to talk about a few ways that Biomarkers of Aging Consortium is working on this problem. So one way is we have the Biomarkers of Aging Challenge. We have a multi-omics data set. It has mortality data. It has health outcome data. We're hosting an open competition. Anyone can bring a model and compare how predictive their model is versus other models. And we're launching in October with phase 3 to predict disease outcomes. There's going to be a $100,000 prize. Anyone can join. I would encourage anyone who is interested to try it out. You can join with the team. We're also doing a longevity study. So we're doing a 5-year study. We're developing a fully open protocol so other studies can use this to also develop more longevity suitable data. And we're planning on sharing this data openly. So join us at the next conference and you can sign up. Another approach is to make unavailable data more useful. So a lot of data is in biobanks, and they are very limited in how much they can or are willing to share this data. It's very difficult to get access to this data. But we've been working on helping these groups standardize the omics data that they have, and we're working on this idea of having a federated benchmarking platform where you may not have direct access to this data, but you could submit a model. We would run it on these data sets that you don't have access to and tell you how predictive that model was in those private data sets. So we could then have more objective measurements of how effective these models are going to be. And if we could get all that together, there's the possibility that at some point in time, that could also be used as a federated learning platform. So we could then access the signal that's in these data sets. So that's my presentation.